Today I'm going to be presenting on carbon capture and our current technologies for carbon capture in 2022. My name is Reid Munro, and I'm currently a second-year chemical engineering student here at UCLA. My first thing I want to go over was just the general overview of how carbon capture works and our general steps that we're using here. So there are three main steps when we're thinking about carbon capture. The first is to actually capture and separate the CO2 from the atmosphere. This can be done at factory locations or at separate buildings which are made specifically for carbon capture. The second step is to transport our CO2 to a permanent storage location. Now, when we're looking at these storage locations, we want long-term CO2 storage. The goal of these plants is to permanently remove CO2 from the atmosphere in order to combat climate change and the greenhouse effect, which is occurring due to the increase in CO2. Now I want to look at some current technology updates that we've had here in 2022. Specifically, I'm going to be looking at Orca, which is a carbon capture plant that is currently in operation in Iceland that was built in the past few years. So this plant is one of the largest plants to date. It's able to capture about 4,000 metric tons of CO2 per year. And it does this through the three steps I outlined earlier. It's capturing CO2 chemically on a filter, which is shown in the phase 1 on the diagram below. And then this CO2, once the filter is saturated, this is heated and the CO2 is able to be released from this filter and then transported to new locations. So once we have this CO2 and we're transporting it to the storage location, we're actually storing it with basalt rock. CO2 reacts with basalt rock to form stone, and this occurs in approximately 2 years. So this is a very renewable process that can be repeated. And again, there are currently new plants in development with many different companies that are similar to this one, but this is just one of the big updates that happened in the past 2 years. Now, a couple of drawbacks of this plant. It's currently about $600 to $800 per metric ton of carbon captured. Now, if we want to be turning a profit with this, we want to get this down to about $150, which is a big jump, but with new developments in technology and more subsidies and government funding, this can potentially be done in the next 10 years. But again, this is requiring a lot of support from outside sources. And the second drawback is the storage technology. So since this is in Iceland, they're able to use the basalt rock, but this is very geology dependent. So if we're having a similar plant in a new location, we're going to have to develop a new form of storage in order to make it viable. And also this 4,000 metric tons of carbon per year is a very small fraction of the actual carbon capture that we're going to need if we want to achieve neutral or net zero carbon emissions. Again, I think this is probably around 1 billion tons of carbon per year that we're going to need to capture. So 4,000 is a very small step, but it is a step in the right direction, which is important to recognize. Now that's my general overview of current carbon capture technologies. I wanted to say thank you to Brandon, Elizabeth, and Professor Lee for making this class possible. I really enjoyed having this class as a way to talk with fellow students about renewable energy and meet people who are also passionate about renewables like I am. Thank you.